Hi everyone. Yesterday we worked on those multi-step equations, in particular with variables on both sides, and I felt we could use a little extra practice because these can be a little tricky. I'm going to put a couple problems up. I will talk through the steps on the first couple and then we'll pause and let you try some. In my first problem, as in any problem, you look to see if there's anything to simplify on the left or the right. Left, 6x plus 15, nothing to simplify, so I bring that down. However, on the right, I'm going to distribute that 3. 3 times 2x is 6x, and 3 times 5 is 15. Now, the next step in simplifying an equation, and isolating the variable is to notice that there are variables on both sides. We will collect them to one side. That's your very next step. This is one of those cases where the variables cancel out. 15 on the left, 15 on the right. That's what we call an identity because it's equal to itself. And so I have infinite solutions, and technically you can just write x is equal to all real numbers because any number I place in there will make this a true equation. On to our second problem. Nothing again to simplify on the left, and this time nothing to simplify on the right. However, we see variables on both sides, so we start off by collecting them to one side. I simplify and I get 3x minus 3 is equal to 21. Two inverse operations. You should be good to go on this. That leaves me with 3x is equal to 24. Divide by 3 on both sides. Solution, x is equal to 8. If I take 8 and check that number in this equation, everywhere there's an x, I'll replace it. 7 times 8 is 56. 56 minus 3 is 53. 4 times 8 is 32. 32 plus 21, 53. It works. On to our next two problems. If you think you've got it, pause and try it, and then check back with me. On the left, we see like terms. Let's combine them. On the right, I see like terms. Those constants can be combined. Now I notice variables on both sides. I'm going to collect them to one side. Here's again an instance where they cancel out. I'm left with two constants, and this says that 2 is equal to 5, which is not true, so I have no solution. What does that mean? There's no value of x when I substitute it in that will ever make the two sides equivalent. Problem number 4. Nothing to simplify on the left or the right, but I do see variables on both sides. This time, I have to add 2x to both sides. Just trying to give you a variety of the different things you can encounter with these multi-steps. Now, two inverse operations. Let's subtract. And let's divide. Again, if we need a little refresher on rules of integers, the operations, we can easily go over them. 4 more problems just to keep the practice going. On the left, I notice like terms, 7x plus x. That'll give me 8x minus 9 on the left. Nothing to simplify on the right. I do see variables on both sides. I'm going to add 4x. That's always your next step, is to get those variables on one side. I now simplify and get 12x minus 9 is equal to 3. Inverse operation tells me to add 9. I'm left with 12x is equal to 12. Divide. Solution. X is equal to 1. Some of them have several steps. This one in particular, let's do a distribution. 2x minus 6 plus x. On this side, we'll have 3x plus 6. Again, combined like terms and a distribution. But wait, there are still like terms. Let's add the x to the 2x. What's my next step? Let's collect variables. It's better to do it in this order. Cancels, cancels. I've got negative 6 is equal to 6. Not true. No solution. Pause and try the next two. Then check back and see how you did. Let's now subtract 6x on both sides. Inverse operation, let's keep going. And divide. They should be getting easier with just seeing more examples and taking it one step at a time. Next problem, nothing to simplify on either side. However, I have variables on both sides. I really want you to get in that habit of collecting them first on one side. We've seen that it works doing it the other way, but this is the suggested way to do it. Let's subtract 7. I'm throwing in some of those negatives again, just to refresh your memory. When you divide and the signs are unlike, you get a negative. So you've seen now 8 more examples of these problems, and hopefully it's starting to fall into place. Now there are going to be times when you're not asked to actually solve an equation, but to test out a solution. And that's really basically what you do when you do a check. So what if I solved this already and for some reason my answer was 4? Let's plug that back into the original equation and see if it makes a true statement, which means I'm going to replace x with 4 anywhere it occurs. Now I'll simplify. So I get 24 on the left, and I'll simplify here, and I'll get 16. That's not true, so that I'm going to say 4 is not a solution. We're just going to draw a conclusion based on the number we're given. Let's do one more. Here's a second equation, and this time I want to do a check and see if 2 is a solution. How do I go about doing that? I take out the x wherever it appears, and I replace it with 2. 6 times 2 is 12. 12 minus 3 is 9. Now I have in parentheses 2 times 2 is 4. 4 minus 1 is 3. 3 times 3 is 9. I can draw a conclusion that 2 is a solution. So sometimes, again, I might just be asking you to check a possible solution. A little preview. We've only been talking about equations with one variable, just x. Now, in our next lesson, we're going to see equations that have both x's and y's. And we're going to be leading ourselves into a discussion about functions and graphing. In this particular problems, we're going to see that this is in what we call standard form, and we're going to be asked to rewrite it into what we call function form, where we solve for x in terms of y. So how do I get y by itself? I'll simply subtract 2x on both sides. I then will have y is equal to negative 2x plus 7, which, if you recall back from a previous class, this looks like y is equal to mx plus b, which is our function or slope-intercept form. And I'll leave you with that thought, and we'll meet up in class today. Have a great day.